if you are a software engineer looking to transition to AI projects or an AI role, it makes sense to understand how transformers work at a deep level. You need to know how transformers work, and for that you need to know how attention works. So that's the mental mind map that we have, and the goal of this session is to help you understand how you can start working on AI projects, and the way you'll get confidence for that is by knowing how things work internally. Let me start with a simple example. Let's assume that you have a query for a large language model. And this model gives you an output. Okay, very standard stuff. You can think of this as ChatGPT. Now, I'll give you an example of the query. The query is, I went to the bank dash. Now, when I say the word bank, what do you think of? Most of you must be thinking of a financial institution where you have all your savings. But bank can also mean river. Okay, so if you are a normal person or a banker or any, if you're related to finance, most likely you thought of a financial institution. But if you are into clearing rivers, if you are a major in geography, you may have thought of river. Okay, so the current thing that we have to remember is there are different words, and some words have multiple meanings. Okay, so firstly, before we get to the depth of this, I went to the bank. Can anyone help me complete this sentence? In the output, what can I expect to get? I went to the bank. Next word could be to, next word could be make, next word could be a, next word could be deposit. Okay. We went to the blood bank, a gene bank. Yeah, Nikhil, that is also a very interesting way to think. So it's no longer a financial institution, it's actually a storage facility. So banking means something, but just bank might be just the storage facility. I went to the bank today. So that's a good example. So example number 1, possible output. Example number 2, possible output. I went to the bank dash today, and Saurabh has come up with this statement. The interesting part is the stop character happens right here. While I could have said to make a deposit also. I went to the bank yesterday. Various examples exist. Okay, how is the large language model actually coming up with this? What's going on internally? Let's see. We have an input statement. We then look at every word of this statement. For now, assume that it's word wise, it's something called tokens. So we'll write down those tokens. For us, the tokens are space separated words. I went to the bank. And what I'll do is note down all the characteristics of these words. Okay, so let me note these down. What kind of characteristics am I talking about? Is it a place? Is it related to finance? And for now, let's just keep two characteristics, okay? So like a typical Excel sheet, rows and columns. All of the columns have all of the words which I input, and all of the rows have characteristics of the words. So let's see. Place, am I a place? No. So I'll give it a value of 0. Want, is wanting a place? No. To, 2 has some relation to place. So I'll just make it a 0.5 or a 0.9. You always go to a place. The has no relation to place. Bank is a place. So I'll give it a relation of 1. Next, I have something like finance. So this is another characteristic of all the words, and you can measure this characteristic. So am I related to finance? No. Want might be related to finance. So I want some money, I want something. So I'll just give it a score of 0.2, low relation. 2, 0, the 0. Bank has high relation with finance, 1. Okay. And similarly, we can take more characteristics. What am I doing here? I'm looking at different ways in which I can measure the characteristic of each of these words. Okay, and what's going to happen is at the end of this, I'm going to have a unique representation of each word. If I keep increasing the number of characteristics of every word, at the end of it, I will have a unique representation for all possible words in the English language. The basic idea is that we want the large language model to generate good output. The only way it can generate useful, good output is if it understands the underlying meaning of each of the words that we have sent in as an input. Okay, so to do that, we need to describe the words, we need to describe different characteristics of every single word in the English language, assuming that the model is English. If it's an image model, then we would need to describe every single characteristic of every image possible. Saurav is asking, so these are basically weights to every words based on probabilities of specific context. Let me describe this in a more clear way. As you add more and more characteristics, for now I will start adding person, right? So if I add the characteristic of person, I has a characteristic of 1, it's a person. Want, can't say. 2, can't say. The, can't say. Bank is not a person, so it will be 0. This is the person characteristic. I can have another characteristic which is computer. Is it something which does computations? I maybe 0.5, want 0, 2, 2, bank. Bank also does computations, so I'll keep it at 0.5. What we are trying to do, don't focus on the numbers so much. Focus on the fact that we are taking every single word which is input to our large language model and we are trying to describe it in the best way possible. If you go along the column vector, then you will get values for every row which uniquely describe this word. Why is this important? Because if you can describe the words, only then can you understand the meaning behind them, and only then can you come up with useful output. So there's a very interesting question from engineer Baucha, which is, where are you getting these characteristics from? Right? For a given query, how do you know how much a characteristic is? We'll not get into that right now. For now, assume that this is happening all magically. We know the characteristic of every single word, but it's actually a neural network which is trained, and it gives out some sort of a row. Some sort of a column for every single word. Okay, we are not going to vectors right now because vectors will be confusing to think of. I'm starting with simple Excel sheet. For every word, we have all the characteristics as numerical values. Okay, but it's not that humans sit down and figure out all the characteristics. That's going to be impossible for all the words in our English language. So this happens automatically through a neural network. They generate vectors. Okay, so these words will have the same numbers attached to them, or will it change according to context? That's a very good question, Prabhat. As you'll see, they will change, but given an input, at this point in the start, you can't tell whether the bank is a financial institution or a river or a storage facility. So the word bank means the same values. This column bank, I just highlight that in green. This column bank, this vector, a 1D array. This is going to be unique and a one-to-one mapping for the word bank. I have no idea whether you are talking about the financial institution, or you're talking about the place, or you're talking about the river. Okay, I am not a river, want to is not, but river is also one in bank. Okay, and someone had mentioned blood bank. So blood is probably 0.5. Storage is probably 0.9. So in this way, you're getting a very unique 1D array, which can uniquely describe this bank. Each of its indices is actually some sort of characteristic. Okay, and if you are able to describe it so well, if you're able to describe every single word uniquely with relevance to the characteristics that it has, then you can assume that the large language model can understand what those words mean and come up with useful output. Its purpose is to come up with useful output. It can only do that if it can derive the meaning. Naman is saying there can be infinite possibilities. How and where will we stop? We'll get to that eventually. For now, just assume that there is a way to stop. There is a way to tell very precisely what every word means. Okay, and we send it to this large language model. Okay, so we have this description. Let me now go for the next part, which is attention. It's much easier than it looks. I mean, the prerequisite for understanding attention is much smaller than most of us would think. Take the same sentence, I went to the bank. Okay, and again take these in the rows also. I've taken the words in the rows and the columns. Okay, it's a n cross n matrix. In our case, n is 1, 2, 3, 4, 5. 5 cross 5 matrix. Take all the input words, put them in rows. Take all the input words, put them in columns. That's all I've done. Okay. This is called the attention matrix. Why? The naming doesn't matter, but what does it do exactly? Take the first word I and I. Find the relation between them. Very high. Of course, it's the same word. So I'll give it a score of 1. Take the second word I and went. Okay. Find the relation between them. What do I mean by relation? I mean that take the first word I, that's over here. That means take the entire column of I, and take the second word, which is went, that's over here. Take the entire column of went and do a dot product on it. Dot product is 0 into 0 plus 0 into 0.2 plus 1 into 0 plus 0.5 into 0 plus 0 into 0 and so on. So you take every row, multiply the values, go to the next row, multiply the values, you do this and then you add all of them together. I'll get a result, maybe 0.01. Okay, so I is related to went with a relation score of 0.01. I do the same thing with I and 2. So the green vector stays the same, I, but 2 is blue, or I'll make it yellow here. 2, 2. Take the entire column, and we are looking at I and 2. So first column 0, second column 0.9. 0, 0, 1, 0, and so on. until I do an addition of all of their row multiplications. Okay, 0 into 0.9 is 0, 0 into 0 is 0, 1 into 0 is 0, and so on. In this way, I get another value, let's say 0.02. Is this making sense? What I'm trying to do is I'm trying to find the relation of every word to all the other words in the text. Why are we doing this? Go back to the original question. Go back to the original problem. When we say I, it's clear what I mean. Okay, this is easy to understand. Went, it is some sort of movement to a place. To, it's to a place. The, some sort of article. Bank, big problem. What do you mean by bank? If I say bank, some people think blood bank, some people think financial institution, some people think that it's the river bank. How do I get rid of this ambiguity? By looking at the other words in the sentence. They give me the context on bank. They tell me what I'm trying to say. So what I need to do is I need to find the relation that bank has to all of these other words, somehow try to encapsulate that meaning in bank, and then if I pass this to the large language model, it's going to come up with very good outputs. It's not going to tell me go to the blood bank, it's going to tell me go to the financial institution. Is this making sense? The reason why we are trying to find relations between bank and all the other words, because bank is an ambiguous word, bank needs context. The context can only be derived from the other words in the same sentence or other words in the same input query. Okay, so our original problem was we have an input text, we want to generate the future of that text. The only way we can actually do this, the only way we will be able to come up with meaningful, useful text that people like is if we understand the underlying meaning behind the input. To derive the underlying meaning behind the input, we try to describe it in the best way possible, but there are some ambiguous words. So to get rid of that ambiguity, we need context from the other words in the same sentence. Is this making sense? Now, our large language model will have a lot of context, will be able to derive the right meaning for the word bank. It won't be some static meaning. It won't be just this vector, it's going to look at the rest of the words and change this vector. It's going to change the meaning. Is this clear? Any questions till now, folks? Let's run through the example. Let's run through the example of bank, right? Take bank and take the word I. So this, let me just get rid of, there are too many lines here. It's going to be very confusing. So I'll just get rid of these things. Yeah. Take bank and first check its relation with I. So maybe I get a value of 0. Now take bank and take its relation with want. Maybe I get a value of 0 again. Take the same word bank, relation with to, value of 0. Take the same word the, bank and relation with the 0. Bank and relation with itself is 1. So what can we see here? We can see that its relation with the rest of the words is 0 and its relation with itself is 1. This means there is no added context from the other words to the word bank. Looking at this sentence, you cannot tell, just looking at the sentence, you cannot tell whether you went to the river bank or the financial institution or the blood bank. Okay. Is this making sense? Let me add another word so that things get easy. Let me add a few more words. So I went to the bank to make a deposit. Let's change this. Make a deposit. All right. And this will also increase the number of columns that we have. Is this making sense firstly? As a human being, can you look at this sentence, I went to the bank, and confidently tell which bank we are talking about? It's impossible. You can't tell whether it's a blood bank or a financial institution. So we need more context. And if you write this in ChatGPT, it's going to assume that it's a financial institution because most of the times you are talking about that. But it's not sure. On the other hand, if I add these words to make a deposit, now again I have an n cross n matrix. I have all these rows and I have all of these columns. I look at the relation of bank with 2, it's 0. Relation of bank with make, 0. A, 0. What about this? Deposit. What do you think the relation of the word bank is going to be with deposit? It's going to be non-zero. Let's give it a value of 0.5. Okay. How did we find the relation? We took a dot product, right, between the bank 1D array and the deposit 1D array. Assume that the deposit 1D array is here. I have the values. Is it, just give me a second here. Yeah, you see, is it a place? No. So I'll give it a value of 0. Is it related to finance? Yes. So 1. So 1 plus 1 is 1. This is where you get the relation. Is it a person? No. Is it some sort of computation? Let's say 0. Is it a river? No. Deposit has nothing to do with a river. Blood, I mean, yeah, you can do blood deposit, but for now assume that these are all 0. But some non-zero relation happened because you had 1 plus 1 here. When you try to find the meaning behind bank, you saw that deposit adds meaning to that word. How is this helpful? Again, coming back to the original problem, you want to generate words. The only way you can do that is by deriving their meaning. Some of the words are ambiguous. To find the contextual meaning, you look at the other words in the same sentence and then you push the word to the right meaning. So bank in our case, because deposit has some relation, we will now make the assumption that you are talking about a financial institution. Okay. Saurabh had come up with an example, which is I went to the bank today. If I use the word today, again, I can't tell. Today has no relation to bank. But someone had mentioned blood. If I say I went to the bank today to donate blood, then what's going to happen in this attention matrix is you won't have the word deposit, you will have the word blood in one of the columns, and that's going to give you a non-zero value, which is going to tell your large language model that, hey, it's a bank, but please push it to the blood meaning, storage meaning. This is really clever. Just think about the fact that you have an input statement. The statement is broken into words. We try to extract as much meaning as we can out of each word. Unfortunately, word meanings are static. The large language model cannot tell if you're talking about apple, whether you're talking about a fruit or a company. If you're talking about a crane, are you talking about the machine or the bird? That's impossible to tell just looking at the words. It tries its level best to derive as much meaning as it can from the words itself by giving them all characteristics. But some words have multiple meanings. In all languages, in Hindi, there's a word called goli, which is basically a bullet or a medicine. And if you're a drug dealer, you think of goli in other ways. So the same word has multiple meanings. And what you do then is look at the context. I can't tell who's typing the input query as ChatGPT. I don't know their life history. So I don't have any context. The only context I can get is from the sentence, the words in the same sentence. That's the idea. The large language model looks at the other words in the same sentence, adds those words, those relations to the existing ambiguous statement, ambiguous word like bank, and therefore bank will now become the final thing is going to be this column. Just give me a second. You're going to have the bank column. I'll give it a different color so that it's clear. Bank will have this column, bank, and 0.5 of deposit. You will have a slightly different vector. The array is going to be changed. Okay. In the other example, it will be bank plus 0.3 blood. These two vectors have different meanings. This is a financial institution. And this is a storage facility for blood. The same word, by having some addition, some manipulation, can give you multiple meanings. This meaning is essential for the large language model to come up with useful output. Otherwise, it's going to assume that you are talking about bank, the financial institution all the time. It can never imagine that you will be talking about the blood bank. We have to look at the rest of the words in the sentence and give it that context. Is this clear? Is it like prompt engineering too? No, Suraj. This is not prompt engineering. Prompt engineering is something that you tell the large language model that you're supposed to behave this way. You have a role, and so attention is to do with getting relevant context from the sentence and adding it to every single word. I'll take another example in the same sentence. Look at this. We said make a deposit. Make. The word make for a C++ programmer means something. The word make for a potter would mean something. So there's a C++ programmer. For them, it's a make file. Make for a potter or an artisan is creating something. And make for us, in the case of deposit, is to set up something. Okay, they are all three different meanings. What will happen through the attention mechanism is this word make will look at all of the columns, all of the other words in the same sentence. I, so value of 0, let's say, went 0 to the bank. Okay, I'll give it a very small value of 0.1 to make a deposit. Deposit is going to give it the meaning of make. So what does make mean in this context? So I'll give it a score of 0.3. So make could have been three different things. In our case, we nudged it towards setting up something. If you had told me I made a file so that I could program faster, then I would have given you program. That word would have sent you towards C++ programming. So every single word in your input sentence is going to go through this attention mechanism and get the useful context that you need for the large language model to give a useful output. So Shivam is saying, how is attention scored different from word embeddings? It's not. It's basically I'm talking about the dot product, which is cosine distance. You can also take Euclidean distance. You are basically trying to find the relevance of one word to another. You can think of this as bank. I think this is the best way to think of it. You can think of the word bank, it's one big word. There is something related to finance, something related to blood, and something related to rivers. If the other words, money, here I'll say flow, in blood I will say be positive. Okay, there are different words which can pull the word bank towards themselves. If you find the words in your sentence, then you start getting a pull. So if you get money or finance, you start moving towards the meaning of financial institution. If you get river or flow, you start moving towards a river bank meaning. If you get blood or some sort of blood type, then you start moving towards the meaning of blood bank. So depending on the words in your sentence, your original word is pulled towards that meaning. There are 3 different directions you can go in. The router says go on this side. This has the most weight. There are other words which are pulling you in this direction. If you don't give it the right weight, if you just say I went to the bank today, then there is nowhere to go, it just stays where it is, and it is ambiguous. You will make the logical decision of finance is close to the word bank, closer than the rest of these guys. I will make the assumption that it's finance. In general, bank is closer to finance. If only you have river and flow, will you actually pull this word towards them? What we did effectively is take all the characteristics of the word bank, take that vector, that 1D array, and add some values from these other vectors to the word bank. It pushed it to the right direction. Now taking this resultant vector, so maybe this is your original vector v1, you took finance, added plus 0.5 v2 to it. Your resultant vector is this, slightly towards the financial institutions. You take this new resultant vector, pass it to the LLM, and the LLM says, okay, I know what you're talking about. It's not just a random, like there's no ambiguity now. I know exactly the kind of bank you're talking about. Let me give you a response. Let me tell you how to make a deposit. Let me tell you how you can write a letter to them. Yeah, Ravi Kiran has a question. Do the same concepts apply in Hindi? Yes. Japanese, yes. So they not only apply to text, but they also apply to images. So if you see a dog and you see the background is a garden, then you will feel like we are talking about a dog in a playground. Okay, but if you see the background is very colorful and completely animated, then this dog is probably animated too. Okay, or a toy dog. So if you see in a movie there's a real dog, but there's a toy who's talking to that dog, then you know that this is a kid's movie. So some context is derived from even images or video. Okay, so these cons. Yes, Sachin, the corpus of training data is extremely important here. Getting enough data to train this model is a challenge. Getting enough compute power to actually train the model is a big challenge. This is expensive to train. We are just talking about the attention mechanism for now. We are not looking at the scale part yet. But you're right. Yeah, so Ashish has an interesting doubt. He's saying, would the bank pull in the case of I went to the bank? So I went to the bank actually is an ambiguous statement. You only know that you have gone to a place, but you don't know which place you have gone to. So bank is not able to pull the other statements correctly. You have to give more context. For example, if you ask it to chat, if you say that I went to the bank, you tell this to ChatGPT, most likely it's going to make an assumption because the vector for bank is going to be close to finance. And so it will make an assumption that you're talking about a financial institution. But if you say, no, dude, I was talking about the river, then it's going to say, I'm sorry. made a mistake. So yeah, that is a lack of meaning in the sentence itself. Are these attention scores generated when user enters a prompt for large language model, unlike word embeddings which are already generated and used as reference? You're right. These characteristics that we talked about, these columns, these are pre-generated. You can think of these as pre-processed. Okay, the way this happens is by training a neural network to cluster similar words together. So word to vec is an easy way to think of this. We'll get to tokenization and vectors in a future video, but for now we have not gone to this because it makes it, attention doesn't really have too much to do with vectors. The concept doesn't have too much to do with vectors. We can understand it even with the Excel sheet. Right, folks. So this is the basic high-level overview of what attention is. It lets a large language model take words as input. The idea is to generate the best possible output that you can, the most relevant output that you can. For that, you try to derive the maximum meaning that you can from every single word. That is a static embedding. That is a static column for every word, a 1D array. You notice that doing this alone is not going to be good enough. You have to add more context to it. Because we don't know who the user is, we don't have any context window initially, assume, we are going to take the other words in the same sentence and add that context to ambiguous words like bank, ambiguous words like river. In Hindi, example of this is goli. Doctor साहब ने मुझे गोली दी means a doctor gave you a goli, it's probably medicine. Police ने उसको गोली मार दी. If police is related to it, then goli is probably a bullet in this context. So the same word goli with a static embedding is not going to be generating good output for the large language model. It will have to start making assumptions. We don't want assumptions. We want accuracy, high context. So that is derived from the other words in the same sentence. So you look at bank and you look at deposit and you say, I know exactly what kind of bank you're talking about. If there was blood, you would have thought of a different type of bank. You would have pushed the meaning of this word bank to the right space.